Everyone, this is my first video. So this video is about the Kadane's algorithm, which is the most famous algorithm, in which we are going to discuss about the problem statement that we are given. Like here we are given, you are given an integer array of array. You need to find the maximum sum of subarray containing at least one element. So one point to notice that there is at least one element to be present to find the maximum sum. So in the array and a subarray description is given, like a subarray is a continuous part of an array. So we are going to find the maximum sum of the subarray that is present in this array we are given. So the first idea that come to my mind is like generating all the sub arrays, then calculating the sum of each sub array, and then these sub array are compared to min value, like extremely min value, and then the result will be like the maximum of all these sub arrays. So like generating all the sub arrays will take of n square time complexity, okay, and then storing will lead to of n square, obviously. I guess it will take of n cube, because each subarray will have some particular length, and there will be at most of n square subarrays. Like how to generate a subarray. Like we will have a pointer I, and which will move from 0 to n, and then we will have pointer j. We will move from I plus 1 to n, and we will have pointer k, which will iterate from I to j. Both are included, and this k will iterate through from I to j, and this will create all the subarray. So we will be storing in a list of integer, and this list will include all the array of from I to j index. Okay, so this iterating itself is of an square, and this iterating through each subarray is also taking off, and this overall time complexity will be O of n cube. So since the time complexity is O of n cube, and we are given constraints of 10 raised to the power 5, this will definitely exceed the time limit. So one of the idea that come to my mind, like to avoid this storing of subarrays, like storing of subarray is unnecessary, because we just have to find the maximum sum of the subarrays of all the among all the subarrays that is present in this array. So we can avoid this. So how can you avoid this? Let's say we have array 1 comma 2 comma 3 comma 4 comma 5. So what a subarray will actually look like, how we actually create it. Like subarray starting from 1, we will include 1, and we will include 1 comma 2. This will be another subarray, okay, and then will be 1 comma 2 comma 3. Like from starting from a particular point, we can generate subarrays. So similarly we can generate for 2 comma 2 comma 3 comma 2 comma 3 comma 4. Okay, similarly we can calculate till the last index. So yeah, in this way we can calculate we can find all the subarrays. So you can find some similarity, like if we start from this subarray, okay, and we will create a some variable so that it will store up to the next element, and then after that element, so it will increase the window. We will increase the window by fixing the left pointer from the ith index. Then in this way we can generate all the sum without even storing all the sub-arrays. So what I'm trying to say, let's iterate through the array. Then for iterating from less than n, we will just take a pointer variable and keeping the left pointer constant, that is I. We will iterate from j less than equal to and j plus till the end of the array. So from that particular index I, we will generate all the sum plus is equal to array of j. Okay, and this will definitely generate all the sub-array sum, because let me give you example, 1 comma 2 comma 3 comma 4. Okay, so starting from 1 we can generate what sub-array sum, like we can generate 1 by taking only 1, we can generate 1 and 2, we can generate sub-array of 1 and 2 whose sum will be 1 and 3, and we can take 1 2 3, and this will give us 6 and up to last element 10. Starting from 2, we can take 2 only, we can take 2 and 3, which will give us sum of 5, and till last we can get up to 12. So we can see that from a particular index I, we can generate all the sub-array sum by iterating just after that. So what I'm doing in this case, like I'm traversing through each index and then keeping a pointer, keeping a sum variable which will store the sum from starting from that point, from that particular point, and this will definitely generate all the sub-array sum, and we will just take the maximum out of them. So this should run fine, and we have also fulfilled the condition of taking at least one index. So let me submit for you, and this will give us a time limit, because the time complexity of this code, so we should have initialized the integer maximum value with minimum value, because there are also some negative element which will contradict the fact that max initial value should be 0, because minimum value will if there is only minimum value, then 0 won't be a physical solution. Okay, so this is giving us time limit exceeded, and there's no wrong case error, because our logic is fine, means we are creating or generating all the sub-array sum and taking the maximum out of them. So there's no as such error in our logic, so we just have to optimize it further. So here comes the Kadane algorithm. So in this, what we will do, we will simulate the sum from 0th index, and we will check if this can be a possible solution. So how would we check whether it is a fine solution or not? So there are some edge cases, like if the element contains, if all the elements are negative, then the maximum will be the maximum among them, maximum sum will be the maximum among them, because the more negative value we add, the more negative it will become. So we won't get the positive, we won't get the maximum integer, maximum sub-array sum. So in this case, we will choose the maximum element, and that will be our maximum sub-array sum. So iterating through array and checking the maximum element. So this will be our initial point. Okay, then we will create a sum array, and then we will store the array length. We will iterate from 0 to n through the sub-array. We will just add all those arrays, and we will take max.max of sum. So here max will only update if the sum will be greater than the maximum value, and in case if sum less than 0, because we won't take 0, we won't take less than 0, we want maximum value. In the only case in which the maximum value will be negative is that all the array elements are negative, and we have already covered that case here, because max will be updated to the maximum value among all the negative elements. So this maximum will not update any, we will not, it will not update anytime. Okay, means the sum won't exceed the maximum value because all the elements are negative, and addition of negative to negative will give more negative magnitude. Okay, so this won't work. So sum, if by chance sum less than 0, then we will just set it to 0 because we are going to take a fresh start of sum, and in this way we would return the max, and this would give us the correct answer, I guess. Okay, yeah, this is working fine. Let's submit it. And the time complexity for this code, this will take O of n, and this will also take O of n, so simply O of 2n, which is simply O of n. That's all from my side. Hope you understand my solution. Thank you.